Hello students, good morning. Today we are going to see the continuation for the lesson 7, that is thermodynamics. What is the topic is pressure, volume, work, relation between the pressure, volume and the work. So that is one experiment is there, that is the work involved in the compression process. So that is the one experiment is there, that is the pressure, volume, work. So that is one container. So one piston is there. So this is the gas molecules are present in that container. So what will happen? We are applying the force. When the force is applied on that, the gases, the volume will be reduced. Okay, so that is, it is reduced in the dx. That is, the area will be represented as A. The pressure will be P. It is a gaseous molecule, gas molecules. When the force is applied on that piston, the volume will be reduced. Okay, so that is the reason. So the pressure will be reduced. The volume is also reduced. Okay, so this is the another one. So we see that one, N is equal to number of moles, area A is equal to area, the total volume, that is first the total volume, how to calculate the initial volume VI, the final volume, that is VF. The pressure inside pressure, that is represented as a P internal. If the external pressure is greater than is internal pressure, so the pressure inside equal to the external pressure. Suppose we are applying the external pressure, what will happen? The internal pressure will be reduced. So the applying forces will be increases, mean the internal pressure will be reduced. Another one is the pressure inside is equal to the external pressure and the final volume is VF. The initial volume is VI, the final volume is VF. Okay, so this is the another one. So next one, so work is done on the system. So already I told yesterday video. So work is done by the system means that is minus W. Work is done on the system means that is plus W. So that is W is equal to minus F into delta X. What is force? Work by area. So that is the force. So that is W is equal to minus F into delta X. So what is here? Force acting on the gas. Delta X is the distance moved by the piston. So that is the distance is moved by the piston, that is delta X or denoted by dx, right? So that is F is equal to, so what is force? Pressure, external pressure into area. So that is the pressure is applied, that is external pressure into area. Substitute this equation, substitute 2 in the equation 1. So what will happen? So W is equal to minus, that is the P external, that is will be applied here, that is P external dot A. So area into delta X. What is delta X? That is the change in volume. Delta X equal to change in volume. That is the one, the pressure is, the force is applied. The pressure will be increases, mean what will happen? The volume will be reduced. So that is the dx, the volume will be reduced. That is V final minus V initial. W is equal to minus P external, V of minus VI. W is equal to external, that is, this is the change in volume. Change in volume is represent the final volume. How to calculate the changes in the volume? So that is final volume minus initial volume. So first enna volume irundhathu adu final enna irundhathu. So the changes will be subtract, so that is delta V. So minus plus, so that is W is equal to external delta V. So W is equal to the positive value means it is work done on the system. So negative means that is work done by the system. Okay, so now that is the positive value, that is work is done on the system, that is the positive quantity. So next one, work done on the system. How to calculate the work done on the system? That is in the reversible reaction. Again, the reaction is considered as a reversible. What is work done on the system? That is the external pressure. That is the external pressure. Initial volume and the final volume, that is delta V, that is dV. In a compression process, the external pressure is always greater than the pressure of the system. So that is when the compression process, the external pressure is always greater. So suppose we are applying some forces, mean that is external pressure will be increases. So that is the compression process. So P external is equal to P initial minus P initial plus changes in the pressure. So the P internal pressure, this is external pressure, எதுக்கு ஈக்குவலா இருக்கும்? internal pressure இருக்கும், total pressure இருக்கும் ஈக்குவலா இருக்கும். In an expansion, P external is equal to P internal minus dP. So expansion, compression means that is the total pressure. So expansion அப்படினா விரியிறது, so that is the internal pressure minus dP. In general, P external is equal to internal pressure plus or minus. So that is it is a reversible process. So in a reversible process, the equation again it is considered VI, that is P internal dV. For an ideal gas of the system, P internal V is equal to nRT. Ideal gas equation, what is the ideal gas equation? PV is equal to nRT. So that is P internal V is equal to nRT. So this can write nRT by V. So that is the internal pressure. Now substitute this in this equation. So W reversible is equal to nRT by V into dV. So nRT is commonly come out. So that is W reversible minus nRT VI by VF dV by V. So that is W reversible is equal to minus nRT ln VF by VI. Okay, so that is W reversible is equal to, so ln is converted into, so how to simplify that? The integral of dV by V is equal to V the whole square VF VI. So how to simplify, differentiate the dV, integral of dV by V is equal to VF minus VI. So how to calculate VF minus VI? Okay, so this can be written, that is ln. So again this can be written ln. So ln VF by VI. So this is the step. This step is not in your book. So directly they are giving this value. So this is the integral of dV by V is equal to V. So again ln VF minus VI, ln is equal to VF by VI. Okay, so that is nRT ln VF by VI. W reversible is equal to ln. So natural logarithm is converted into log. So that is you multiply by 2.303 nRT. So log VF by VI. So this is the another one. VF is greater than VI. It is expansion. It is the negative sign. That is work done by the system. Okay, the negative sign means work done by the system. VF is greater than less than VI, the compression, that is positive sign, the work done on the system. Okay, so this is the relation between the work and the expression. So that is the relation, the compression and the expansion, the volume of the pressure and the volume. So what is the summary? The summary of this volume that can be written like this. The heat is absorbed by the system, that is plus Q. If heat is evolved by the system, that is minus Q. I already told, absorbed by the system plus Q, evolved. So heat வந்து வெளியில போகுது அப்படினா, that is minus. Work done by the system, work வேலை the system வேலை செய்து அப்படினா, that is minus. Work done on the system, அந்த சிஸ்டத்து மேல வேலை செய்து அப்படினா, that is plus W. Okay, so this is the another one. Next we are going to see the zeroth law. What is mean by zeroth law? Zeroth law, first you understand that what is zeroth law. So first we are consider the three container. So suppose we are taking the two container. It is maintained the temperature is, this is 60 degree. This is also 60 degree. The third container is a normal. So this is the boiling water, 60 degree is maintained. So here the both the container contain 60 degree. But here is no temperature. So this is the normal water. But the three beaker is kept under the thermal equilibrium. What will happen is a thermal insulated material. What will happen? So after some time, the third one is also maintained the 60 degree. So that is called as zeroth law. So if two systems are separately is thermal equilibrium with the third one, then they tend to be thermal equilibrium with themselves. So what is the meaning for that? ரெண்டு சிஸ்டத்தை நம்ம தனியா thermal equilibriumல வச்சோம் அப்படினா, third one is attained the thermal equilibrium. So that is the zeroth law. If two systems are separately in thermal equilibrium with the third one, then they tend to be in the thermal equilibrium with themselves. Okay, so this is the another one. This is zeroth law, very important law. Okay, so this is the another one. So next we are going to see the first law of thermodynamics. What is first law of thermodynamics? So everyone know about the law of conservation energy. Law of conservation energy. The energy neither created nor destroyed, but it converted into one form to another form. This is the first law of thermodynamics. So that is delta E is equal to Q plus W. What is delta U? Change in internal energy. Heat is absorbed, heat is supplied, and W is equal to work done on the system, plus W means that is work done on the system. Heat is absorbed or heat supplied, that is delta U. So what is the first law of thermodynamics? The energy can neither created nor destroyed, but may be converted from one form to another form. So this is the first law of thermodynamics. The energy can neither created nor destroyed, but may be converted from one form to another form. So delta is equal to Q plus W. So in some cases for a cyclic process, For a cyclic process, delta U is equal to 0. So this term becomes 0. So what will happen? Q is equal to minus W. So from this, for a cyclic process, work done for this is the work done by the system. Minus W is equal to work done by the system. So heat absorbed is equal to the work done by the system. So ஒரு cyclic processல heat absorbed எதுக்கு ஈக்குவலா இருக்கும்? அந்த system வேலை செய்யறத பொறுத்து இருக்கும். So next one is for an isochoric process. What is isochoric process? Isochoric means that volume becomes 0. So volume constant, volume becomes 0, delta V equal to 0. So delta U is equal to, so Q plus W. So that is the heat absorbed, work done. So what is W? Work done is equal to minus P delta V. This is, we already know that this is important one step. W is equal to minus P delta V. So now you substitute this one, this W, Q is equal to minus P delta V. So delta V already 0. So this is the condition for a isochoric process. Delta V is equal to 0. So that is delta V equal to 0. So delta U is equal to QV. So that is the heat absorbed by the volume. Okay, so this is the another one. So another cases is isoboric process, pressure. So for an adiabatic process, Q is equal to 0. What is adiabatic process? The heat cannot exchange with the system and the surroundings. So that is the adiabatic process. So that is Q is equal to 0. So Q means the temperature remains constant. It cannot exchange with the system and the surroundings. Q is equal to 0. Delta U is equal to Q plus W. So delta U is Q and the 0. So delta U is equal to W. So another one is isoboric process. What is isoboric process? Pressure remains constant. So that is delta U is equal to Q plus W. Delta U is equal to Q minus P delta V. So this is the isoboric process. Next we are going to see the new term, that is what is meant by enthalpy. What is meant by enthalpy? Enthalpy is defined as the sum of the internal energy and the product of pressure and the volume. H is equal to U plus PV. So what is H? H is equal to enthalpy. What is enthalpy? Enthalpy is defined as the sum of internal energy and the product of pressure and the volume. So enthalpy, delta H, change in this enthalpy, temperature and the internal energy, we can write delta H is equal to delta U plus P delta V. So otherwise we can write delta H enthalpy எதுக்கு ஈக்குவலா இருக்கும்? Heat absorbed by the system at constant pressure. That is delta H is equal to QP. So next another one important 5 mark question. What is the relation between enthalpy and the internal energy? What is the relation between enthalpy and internal energy? H is equal to U plus PV. So that is the another one. H is equal to U plus PV. So here that is, it is the initial state. Initial state means we are considered the enthalpy, internal energy, pressure and the volume initial state. H1 is equal to U1 P at constant pressure, that is V1. Final state H2 U2 PV2. So change in the enthalpy. So that is final state minus initial state. That is H2 minus H1 is equal to U2 minus U1 is equal to P into V2 minus V1. So that is the final state to initial state. Delta H is equal to delta U plus P delta V. Okay, so that is the change in the enthalpy, internal energy and the volume. First law of thermodynamics state that delta U is equal to Q plus W. What is delta H? Delta H is equal to Q plus W. Now you substitute delta U in Q plus W. You substitute in this value delta H is equal to Q plus W plus work. What is work? Delta H. So delta H is equal to Q plus W plus P delta V. So delta, what is delta? Internal energy, Q plus W. Delta H, now you substitute this one for equation 1. Delta H is equal to Q plus W plus P delta V. What is W? That is minus P delta V. That is the delta H is equal to QP. Now minus P delta V plus P delta V. The P delta V cancel. So delta H is equal to QP. QP, heat absorbed by the system at the constant pressure. So now again this equation becomes, now you consider this equation. So that is ideal gas equation. What is ideal gas equation? PV is equal to nRT. For initial state, for the reactant and the product, how to write? Initial state of the reactant PVI, the initial state of the reactant N initial state NI NiRT. For product, PV final is equal to NFRT. So, final value minus initial value is equal to final minus initial. Number of moles for final and the initial. So, that is equal to P delta V, change in volume. So, that is delta number of moles in gram RT. Substitute P delta V in the equation 1. So, now you substitute this value in this equation 1. So, what is this equation? This is the equation delta H, P delta V. Instead of P delta V, you substitute delta Ng RT. Now, you substitute that value. P delta V is equal to delta H is equal to delta U plus delta Ng RT. Okay, this is the relationship between enthalpy and the internal energy. Once again, so very important one. First, we are writing the enthalpy equation. H is equal to internal energy and the sum of the internal energy and the product of pressure and the volume. What is the initial state? H1 is equal to U1 and PV1. P is a constant. V1 is the initial state. And the final state means that is H2, U2, PV2. Change in enthalpy. H2 minus H1 is equal to U2 minus U1. So that is the change in the enthalpy. Write it here. Delta H. Change the internal energy delta U. Change in volume, that is delta V. First law of thermodynamics, delta U is equal to Q plus W. So that is the first law. Change in internal energy, heat absorbed by the system, work done by the system, work done on the system. Delta H is equal to Q plus W plus P delta V. W is equal to, you already know that W is equal to pressure into volume. So that is delta H is equal to QP minus P delta V, cancel. Delta H is equal to QP. Now you consider the ideal gas equation. PV is equal to nRT. For reactant, PVI is equal to NiRT. For product, PVF is equal to NFRT. So final minus initial value, you can write delta NgRT. Substitute this one in this delta H value, delta U plus delta NgRT. Okay, this is the important 5-mark question, repeatedly asking question. So next we are going to see the standard heat of formation. What are the standard heat of formation? Standard means the change in enthalpy at the standard condition. Standard condition means what? So at 298 Kelvin at 1 bar pressure. What is 298? 35 degrees Celsius. So that is 25 degrees Celsius. So the change in enthalpy that takes place when 1 mole of a compound is formed from its element present in the standard state. What is the standard state at 298 Kelvin, 1 bar pressure? Okay, this is the standard condition. 298 Kelvin means that is 25 degrees Celsius. So how to calculate 25 degree plus 273? So that is the 298 Kelvin. This is the another one. Then 1 bar pressure. The change in enthalpy takes place when 1 mole of a compound is formed from this element present in the standard state. So what is mean by standard condition of enthalpy? So standard heat of formation that takes when 1 mole of a compound, 1 mole compound எடுத்து present in the standard state ல வந்து எவ்வளோ heat வந்து form பண்ணுது, that is called as standard heat enthalpy. So that is the example: iron, sulfur, ferrous sulfide, then delta HF value, that is minus. This is also carbon when burned with hydrogen to form ethylene. So that is delta HF is equal to plus 2. So this is the another one equation. This minus value means that is heat evolved. So delta HF, that is formation, heat is absorbed. Okay, plus value means that heat is absorbed, minus value heat is evolved. So another one, thermochemical equation. Next we are going to see the thermochemical equation. So what is mean by thermochemical equation? So first one, so what is thermochemical equation? Thermochemical balanced stoichiometric chemical equation that includes the enthalpy changes. So that is say for example, we are considered one the balanced stoichiometric chemical equation. We can easily understand what are the characteristics of this compound and the chemical reaction. What is the nature of this reaction? We can easily understand that. So what are the point? First you remember that first one is the coefficient in the this is one balanced chemical thermochemical equation, right? 2H2O2, 2H2O. This is the one balanced chemical equation. First, from this equation, how to tell that 2 mole of hydrogen, 1 mole of oxygen react to form 2 mole of water. Okay, so this is the coefficient value is indicate number of moles of reactant and number of moles of product. involved in the reaction. The coefficient value is represent number of moles of reactant and number of moles of product. Okay, so this is the another one. So next one is enthalpy change of the reaction. Delta HF has to be specified with the appropriate sign. So that is the enthalpy of reaction. This is the appropriate sign. So that is the heat is evolved or heat is absorbed. So appropriate sign will be indicate. That is the second point. Next one is when the chemical reaction is reversed. Suppose the same equation is reversed, means the formation of this enthalpy value is also reversed. Suppose this is the formation forward reaction, this is the reversible reaction. Now the reaction, the same value, the reverse sign. So this is negative sign, this is the positive sign. Another one is from this equation we can understand that it is a physical state of this equation. This is the hydrogen gas. This is oxygen is also gaseous molecule. Then this is also gaseous molecule. So from this we can understand the physical state of this state, that is gases or liquid, or indicate this bracket. So that is the physical state of this equation, depends upon the physical state of the reactant and the product. And next one is throughout by the number. If the thermochemical equation is multiplied, suppose we are balancing that equation, this is also gaseous state, this is also, suppose we are balancing the thermochemical equation, we are multiplying any number, means you can multiply the enthalpy value also. Okay, this is another important one point. So suppose you are multiplying, you are balancing the thermochemical equation, you are multiplying any number with the reactant or product, you can multiply also the enthalpy value. Okay, this is the another one. So next one is the negative sign is indicate is the exothermic reaction. So exothermic means that is the heat evolved. The negative sign indicate is the exothermic reaction. The positive sign they represent is the endothermic. Endothermic means heat absorbed. Endothermic. Okay, this is endothermic, exothermic. Exothermic means that is heat evolved. Endothermic means that is heat absorbed. Okay, so this is the another one. This is the equation. From this equation we can understand 2 moles of hydrogen, 1 mole of oxygen react to form 2 moles of water in the gaseous state. The enthalpy of reaction minus 96.4 kilojoule mole minus 1. It is an exothermic reaction. From this one equation we can easily understand the nature and the state of this equation. Okay, this is the thermochemical equation. Next we are going to see the what is meant by standard enthalpy of reaction. So when all the reactant and the product are present in this standard state. So all the reactant and the product are present in this standard state, that is called as heat of standard enthalpy. What is standard state? 1 bar pressure at 225 degrees Celsius at 1 atmospheric pressure. Okay, so that is called the standard state. It is represented as superscript 0. So that is enthalpy. Standard enthalpy means delta H0. So that is what is the standard state of this delta H0. Delta H, what is the formula? How to calculate standard enthalpy of the reaction is equal to sum of the reactant minus sum of the that is the product minus reactant. So sum of the enthalpy of the reaction of the product minus enthalpy of the reactant. Okay, so this is the another one. So they give one example. What is that example here? First one is, consider one equation, the standard enthalpy of formation of ethyl alcohol C2H5OH liquid plus in carbon dioxide and water. This value is minus 277, this value is minus 393.5, this value is minus 285.5 kilojoule mole minus 1. This is the 3 value they already given. The calculate the standard enthalpy change. So first you write the equation right here, that is C2H5OH plus 3O2 2CO2 plus 3H2O. Okay, so this is the equation. From this data we can write the equation. Okay, what is the solution? So first we are going to calculate the delta H. What if first you write the formula? What is the formula? Delta H reactant is equal to standard enthalpy change of this equation is equal to delta H formation of products minus delta H0 production of reactant. This is the formula. So here delta H0 R is equal to, what is this equation? What is the product? 2 carbon dioxide, right? 2 into delta H formation of carbon dioxide, right? So that is carbon dioxide. Then plus 3 molecule of H2O. H2O value already given, so that is H2O. Delta H formation of H2O, that is the product, minus what is 1 mole, that is C2H5OH, 1 of delta H C2H5OH plus 3 into delta HEF 0 of oxygen. Okay, so this is the formula. So how to write 2 mole? So already 2 mole is there. What is the delta HF value of carbon dioxide? How much? Minus 293 Kelvin. 2 into minus 393.5 plus 3 into water. What is the value of water? Minus 285.5. Then minus, what is that value? 1 into minus 277 plus 3 into 0. So oxygen value is not given, mean that is we assume 0, right? This is that value. Okay, from this we can how to calculate that one. So here, so 2, that is minus 787 minus 856.5 minus of minus 277. Okay, so this is the another one. So this is simplifying that. How to simplify that? Minus 1643.5 plus 277 equal to minus 1366.5 kilojoule mole minus 1. Okay, so this is the answer for this sum. So first you are how to calculate the enthalpy of heat formation. So that is the this is the formula, product minus reactant. So that this is value already given. Just you simplify that, you can easily calculate it, that one. So this is the sum of this another one. So next you are going to see the what is mean by heat of combustion. What is mean by heat of combustion? The change in enthalpy of the system when 1 mole of a substance is completely burnt in excess of air or oxygen. So what is mean by heat of combustion? So the heat of combustion again, that is the when 1 mole of a substance is completely burned in excess of air or oxygen. So a complete burn ahi evlo heat evolve agudho, that is called as heat of combustion. So example, methane when burned with oxygen to form carbon dioxide and water. So what the heat of combustion is? Minus 87.78 kilojoule. Okay, so this is the heat of combustion. Okay, that's all about this today's video. We see the next video, molar heat of capacity. These are the, we see the tomorrow. Okay, thank you children. Bye.